Okay, so yeah, so all those videos are linked there in today's classroom. It's kind of like a playlist. I wanted to put a link to the playlist. I think if you click on this link, it'll take you to this video, one of these, this video, and then I think you can see the playlist in there. I created a Math 3 playlist. So if you click on the playlist in the channel, then you can see all the videos that I've uploaded from this quarter on the Math 3 playlist. So my channel is a Math Magical Life. So if you click on any of those videos, it'll take you to my channel, and then hopefully you can see the playlist too. Okay, thank you for the message. So you were supposed to, let's see, turn in homework. 23 of you have turned it in, adding and subtracting rational expressions, right? So that was due, 14 problems there, not too bad. And so that was due, and hopefully more of you are going to turn that in. And classwork, let's see, I graded 13 of them that day, and I need some more of you turned in stuff before the deadline, so I'll grade that later. And today we're going to go on to 11.1.4, which basically is kind of putting together everything that we've done in chapter 11 so far. So I definitely we're going to do 38 through 40, so you can write this at the top of your paper, 11.1.4, 38 through 40, and 42, 43, and 47. So we're going to do 38 through 40 together, and then you're going to finish up 42, 43, and 47, add that to your assignment, and do tonight by midnight. You know, hopefully you get it in by the end of class or 3 p.m. The sooner you get it in, the sooner I can grade it. If you wait till midnight, I won't grade it till another time. But if you turn it in before like 3, I'll try and grade it today. Like I said, there's going to be a quiz on Friday, a chapter 11 quiz. So here are all the videos for chapter 11, including the one I'm going to make today. I'll post probably later today too. So if you need to review any of these, then you can, click on them and watch them. And then your homework today is a worksheet. Like I said, pulling all of 11.1.1 to 11.1.3 together. And it's actually 2 pages. So make sure you scroll down to the bottom. There's 26 problems. You can see these top ones are pretty easy. We're going to go over some of these latter ones. The multiplying and dividing is pretty much what I go over in the notes. So not too worried about that, but I'm going to go over some of these bottom ones here in our classwork today. All right, so let's get started on the notes for today and go ahead and put 11.1.4 on your paper. Let me change color here. Okay, putting it all together. All right. In this lesson, we will use all 4 operations: adding, subtracting, multiplying, dividing, right, of arithmetic to combine rational expressions. What operations are we using, and what steps will we need to take? Are the numerators or denominators of the expressions factorable? If things are factorable, you want to factor them. If you're not factoring, you're not doing the homework correctly. How can we use the multiplication property of 1? Okay, so number 38, starting with number 38 here, A. Let's go ahead and write this down. A says 5/8 plus 1/6. This isn't even an algebra problem. This is a basic arithmetic problem. We add and subtract, right? We were adding here fractions. We need a common denominator, right? Common denominator. Okay, well, what is the lowest common multiple of 8 and 6? What is the common denominator that we're going to make? Anybody know what the lowest common multiple is of 8 and 6? What is it? Take a minute to think about that. And you just have to think of the multiples of 8 and 6. When I think about it, I thought, 24. Both of them can be 24, right? So we need to get them to be 24. So to do that, to get 8 to be 24, I'm going to multiply by 3. And I have to multiply by 3 over 3, right? I have to multiply by a gigantic 1. So if I multiply the bottom by 3, you got to multiply the top by 3. To get 6 to be 24, I'm going to multiply by 4. If I multiply the bottom by 4, I got to multiply the top by 4. So let's go ahead and multiply our numerators. 3 times 5 is 15 over 24 plus 1/6 times 4/4 is 4 over 24. Now that we have a common denominator, you know, the denominator stays the same. And we just add the numerators. 15 plus 4 is 19. So the answer to this problem is 19/24 after we find a common denominator. Okay, part B here, 8/9 minus 2/3. Okay, I know I can make 3. 9 is a multiple of 3, so I can make 3 into 9 by multiplying by 3 over 3. Right, so go ahead and finish that problem for a second while I take a look at the participant list here. I know one of you was having Wi-Fi issues, so I want to see if that person made it to class or not. Oh yes, they're here. Good to see you guys here. Okay, hopefully you're paying attention, taking notes, because you're going to turn this in for credit. So we have our 8/9. We don't have to do anything to that. This, we're going to multiply 2/3 times 3/3 is 6/3. So minus 6/9. And this is going to be 2/9. We subtract the numerator, the denominator stays the same. We try and reduce, but we can't reduce 2/9. So the answer is 2/9. Okay. All right. Go to the next one, C. Go ahead and copy down C. While I turn my paper, correct page. Okay. Move this down. I can't move it down. So C says, what does C say? Oh, that's pretty easy. X plus 5. They already have a common denominator, so this is a super easy problem. X over 5, X plus 5 over X plus 2 plus 2X plus 1 over X plus 2. Common denominator, easy. So the denominator stays the same, X plus 2. So we're just going to add the numerators, what the like terms. X plus 2X gives me 3X. And then the positive 5 plus the 1, that's your other like term. So 5 plus 1 gives me 6. Okay, and you might stop here. If you stop here, you wouldn't be done. Okay, because I noticed that the top, the 3 and the 6 have something in common. So you need to factor. Anytime you can factor something, you want to factor it, right? It says, is it factorable? Yes, the numerator is factorable. What can we take out of 3x and 6? We can take out a 3 out of there. So if I take out a 3 out of this, I'm left with x plus 2 over x plus 2, right? So I can cross out the x plus 2's. They divide out, right? Those become 1's. So all we're left with is just 3. So the answer to this problem is 3. Now, did I just write 3 and say, oh, the answer is 3? No, there was a lot of work to show. So you have to show work for this stuff. Okay, let's go to D here. D says x squared minus 3 all over x plus 5 times 2x minus 1 plus x over 2x minus 1. I'm going to put a parentheses around that. Notice they don't have a common denominator. Like these denominators are not exactly the same. They're very close. They do have a common factor, so that's good. But I need to make this fraction into this fraction, right? So this is part of like what your homework is like. So I need to multiply by what's missing over here, right? This has it. They both have a 2x minus 1, but this is missing an x plus 5. So I need to multiply by x plus 5 over x plus 5. Okay. And so the common denominator is going to be 2x minus 1. I'm just copying this part right here, times x plus 5, right? That's the common denominator if I multiply this. Now this part stays the same. I don't have to do anything to the x squared minus 3. This part I need to multiply by the thing that we multiplied by over here. So x times x gives me x squared. And then x times 5 gives me 5x. Okay, so we simplify down to that. Now we have to take the numerator and combine like terms. So the x squared goes first. There's x squared plus another x squared So x squared plus x squared is 2x squared. And then we have a plus 5x. And then we have a minus 3. So we put them in order, descending order. And then the bottom is 2x minus 1 times x plus 5. Okay, now the fact that this is a trinomial tells me I'm not done yet. I need to factor this, and maybe it'll cancel out with one of these, right? So if I factor this, I'm going to just do it right above because I'm kind of want to save space. I don't want to write as much. If I factor 2x squared, I'm going to break that down to a 2x times an x, right? Factor that. Now I'm going to factor the 3. And I can either put 1 and 3 or 3 and 1, and only one of those is correct. Because this is a minus, that tells me that the signs are going to be plus and minus. One's going to be minus, one's going to be plus. And I need a positive 5. So that tells me I want this to be 6. So I'm going to put 3 here and the 1 here. And let's try it. If it doesn't work, then we'll erase it. Okay, so I'm going to erase this stuff. And let's try 2x. We're going to multiply the outer terms, right? We're kind of foiling here. I'm doing the outer and the inner terms. 2x times 3 is 6x. And then the inner term, 1 times x is 1x. I need it to be a positive 5. So this has to be positive and that has to be negative. So since I need the 6 to be positive, I would put the plus here. And I need the 1 to be negative. I would put the 1 there. And look what happens, guys. There's a 2x minus 1 on top and bottom, right? So this is no longer this. It's this times this. So let me change my color here. And I'm going to cross out this 2x minus 1 and that 2x minus 1. What are you left with? X plus 3 over x plus 5. Okay, you cannot cross out the x's. Don't do that because there's pluses connecting the x plus 3 and the x plus 5. So that is how you properly add two polynomials together, finding a common denominator, and then factoring out the trinomial to cancel out the common terms to get this. And that's the only way you can get this answer. Okay. Next problem. I got to clear this away. So if you need to take a screenshot, please do so. If I went too fast, or watch the video. Going to clear out this drawings, go to the next page, 39 here. So let me get my pen back. Examine the addition problem below. Okay, I want to add these two. Do they have a common denominator? No. Okay, decide how to rewrite the fractions so that they have a common denominator. B, if you have not already done so, add the fractions. Okay, so they don't have a common denominator, so we need to make it a common denominator. 11-39. A says 2x minus 1 over, let's go ahead and write it, 3x squared plus 13x plus 4 plus x plus 3 over x squared minus 3x minus 28. Not common denominator. So what we need to do is factor both of these two to see if they have common factors. So I need to factor this one and I need to factor this one. They're low numbers, so I could use the X box method, but since it's low numbers, I don't really need to. To factor 3x squared, I would do 3x times x, right, to get that. To factor 4, and I want to keep in mind, I want to try to get 13. Well, I'm going to put the 4 here because when I multiply 3x times 4, that's going to give me 12x. And that means I'm going to put the 1 here because 4 times 1 is 4, and then 1 times x is 1x, right? So I'm going to use this 1x and this 12x to make 13. Well, they're both positive, so it means this has to be positive and this has to be positive. So this is going to be positive and this is going to be positive. So that's how we factor 3x squared plus yada, yada, yada factors down to this. To factor this trinomial is pretty easy. X times x gives me x squared. And then I'm going to put the factors of 28 here. When I think 28, I know my times tables. That's 4 times 7. Right? If you don't know your times tables, look up that chart that I linked a long time ago. And I want it to be a -3. So that means that the 7 needs to be negative and the 4 needs to be positive. Okay, now look at what we have here. they both have an x plus 4. So that's part of the lowest common multiple is x plus 4. I don't have to worry about that, right? Let me erase part of this stuff here, this to go away. So what I need to do is I need to, okay, what's the lowest common? Well, they both have an x plus 4, so I don't have to worry about that. So this part is missing, right? This part is missing a 3x plus 1. There's no 3x plus 1, but there's a 3x plus 1 over here. So we need to multiply by 3x plus 1 over 3x plus 1. And this part has been changed to this, so I'll cross those out. For over here, we are missing what space do I have here? I'm going to do it over here. Okay. This one doesn't have an x minus 7, so we need to put x minus 7 over here. X minus 7, and I didn't have room here, so I'm going to do x minus 7 right there. Okay, so I'm multiplying by x minus 7 over x minus 7, which is a giant 1. Okay, now they're the same. They both have a 3x plus 1. They both have x plus 4. They both have x minus 7. That's the lowest common multiple of those two. So part B says, hey, add these together, right? So let's add these together. To add these together, we have to multiply this. I'm going to show you the FOIL method, okay? So kind of need more space here. 2x minus 1 times x minus 7. If you wanted to use the boxes, you can use the boxes to multiply it. That's fine. I'm just going to use the FOIL method. You know, FOIL stands for first, outer, inner, last. Those are the 4 multiplications. So 2x times x, that gives me 2x squared. That's my first, outer, inner, and last. Outer, inner, last. Okay, if you were in my math 2 class last year, I showed you how to do this in there. Okay, and then 2x times negative 7, when I multiply 2x times negative 7, that gives me negative 14x. Okay, and there. Okay, and then let's do the inner terms. Negative 1 times x is negative x. And then the last term is negative 1 times 7, right? Negative 1 times negative 7, which is positive 7. Okay, so that is the first part. That is this times this. Okay, all that stuff is this. Now I need to do this times this. Same thing, but over here. So I need to do the x plus 3 times the 3x plus 1. Same type of deal. So I'm going to do like x plus 3 times 3x plus 1. First, outer, inner, last. Let me erase this box here. It's kind of in my way. Okay, so first, outer, inner, last. It makes a big happy face. First, outer, inner, last, right? So x times 3x is my first multiplication. That is 3x squared. So plus 3x squared. My outer terms is x times 1. That is 1x. My inner term is 3 times 3x. That's 9x. My last term is 3 times 1, which is positive 3. Okay, first, outer, inner, last. FOIL. First, outer, inner, last. First, outer, inner, last, right? We did FOIL twice. Once for these two and once for these two. Okay, now we got to start combining a bunch of stuff. And I need to erase my FOIL that I wrote. Okay, and I see some like terms I could have combined. So I'm going to go ahead and combine these middle two here. What is negative? When you do FOIL, you can always usually combine the outer and the inner terms. So these are our outer and inner terms in the middle. Negative 14x minus x is negative 15x. Right, so that's a negative 15x. And then, let me cross those out. And then these two, these are my middle terms here. 1x plus 9x is 10x. So I can cross those out. That's a 10 now, 10x. So now we have trinomial plus trinomial. And the bottom stuff is the same, right? It's x minus 7 times 3x plus 1 times x plus 4. I just copied the denominator right here. Okay, now we have to combine like term stuff. So 2x squared plus 3x squared is 5x squared. Okay, and then our x's, negative 15x plus 10x is negative 5x. And then lastly, our constant 7 plus 3 is 10. Okay. And then our denominator just remains the same. Do not multiply these out, right? We're going to keep them the same. We're going to keep it x minus 7. You never multiply the denominator out. The numerator, yes. The denominator, no. X plus 4. Okay. Now, I kind of see that I can factor a 5 out of all these. These all have a common factor of 5. So I'm going to take out a 5. 5 times x squared minus x plus 2. If I take a 5 out of all these, that's what I'm going to end up with. And the denominator, we just leave it alone. X minus 7 times 3x plus 1 times x plus 4. Okay. And since I have a trinomial, I'm going to try and factor this. And this indeed can factor because this is a 2 and this is a 1. So it can definitely factor. So if I factor it, I'm going to get x times x for my x squared for my factor of 2, 1, and 2. And I need a negative 1. So the 2's got to be negative. The 1's got to be positive. And the denominator stays the same. X minus 7 times 3x plus 1 times x plus 4. Okay, and I would like something to cancel here, but unfortunately nothing came out to be the same. So this is just how we're going to leave it. Okay. Your book actually has this, they leave it like this, but how do you know that this can't be factored? You'd have to factor it first. You'd have to factor it first to see if it can be, and you want to do this. So either answer is okay. Okay, I'm gonna, I need to erase this half. So if you need to take a screenshot, do so. I can erase the FOIL part first while you're doing the answer part. Let me erase this. Okay, we're going to do C here. C. C says 2 over x plus 4 minus 4x minus x squared over x squared minus 16. Okay, no common denominator. It's a subtraction problem, so they need to have a common denominator. Well, this can be factored, so I'm going to go ahead and factor this. This is a difference of 2 squares. This is x plus 4 times x minus 4, right? I could do the square root thing, like that's a perfect square, that's a perfect square. So we can do a difference of 2 squares, which I call dots, difference of 2 squares. Okay, and that's how you factor it. And therefore, we would need to multiply this side by, it's got an x plus 4 here, and there's an x plus 4 here, so it's just missing an x minus 4. So I need to multiply by x minus 4 over x minus 4 to make a common denominator. Okay, so we're going to take this 2 and distribute it with the x minus 4. 2 times x minus 4 is 2x minus 8, right? And then here's the tricky thing. When you have a subtraction problem, you have to multiply it by everything. You have to distribute this negative. It's a negative, and you have to distribute it to both of them. That's going to change this to positive, because most people are going to say, oh, this is minus 4x. But then a lot of people aren't going to change this negative times negative to positive x squared. A lot of you are going to put minus x squared, and you're going to get it wrong. You have to distribute the negative to everything up here, and that changes that negative to a positive. The bottom is just going to be x plus 4 times x minus 4. And so what do we have here? We have x squared first. And then let's combine our like terms. 2x minus 4x is minus 2x. And then lastly, we have minus 8 over x plus 4 times x minus 4. And I think we can factor this. This is a trinomial, so let's try and factor it. Let's put a negative 8 and a negative 2. Well, I know 2 times 4 makes 8. And if I add these, this could be negative, this could be positive. So that actually factors down to, this factors down to x plus 2 times x minus 4, right? So I'm going to change this to x plus 2 times x minus 4. And look, the x minus 4s are the same, so we want to cancel those out, leaving us with x plus 2 over x plus 4. Could you put an excluded value? Sure, you could put x cannot equal -4 for your excluded value, okay, just to throw that in there. So that is how we factor and cancel out what they have in common to get our answer, okay. I need to erase this and go into the next screen. So if you need to take a screenshot, go for it.
Ms. Wakefield?
Yes. Wait, hold on one second.
On the test, you want us to include the exclude values?
Yeah, so on the test, usually it'll say state the excluded values. So you'll know you need to put excluded values. If it doesn't, go ahead and put them anyways, and that just to be safe. Okay, next slide. 40. Okay, this is kind of the last problem. We actually have to do a worksheet problem. So pulling it all together, you now know how to add, subtract, multiply, and divide rational expressions. So we're going to do all of them. We're going to add, subtract, divide, multiply, add, subtract, and divide, just to review, okay? Because we haven't done any division or multiplication review today. We did that a couple days ago. So let's do A here. Change my color. Okay, so A, number 40A, 2x squared plus x all over 2x plus 1 quantity squared minus, there's that minus, they're trickier if they're minus, 3 times 2x plus 1. Okay, if we notice that, hey, they both have a 2x minus 1, 2x plus 1, but this one has 2 of them, so we need to multiply this side but by another 2x plus 1. So 2x plus 1 times 2x plus 1, right? To get 2 of them, because we need 2 of them, not just 1, to make a common denominator. So let us put this 2x squared plus x, right? You don't have to do anything here. My denominator is going to be 2x plus 1 squared, because we have 2 of them, so we could just write it like that. Now I need to distribute this 3, but remember, it's actually a -3. See this minus? That's a -3 times 2x plus 1. So that's going to make both of these negative. So -3 times 2 is -6x. -3 times 1 is -3. Okay, that's important that both of these become negative. Now we're going to combine like terms. So if I combine like terms, well, first I'll start with 2x squared. There's nothing to combine there. And then I have a 1x minus a 6x, that's minus 5x. And then minus 3 all over 2x plus 1 squared. I suspect we can factor this because it's a trinomial. So to factor 2x squared, I would go 2x times x. To factor 3, I could do 1 and 3 or 3 and 1. It makes a difference if I go 1, 3 or 3, 1. Well, I want a -5, and I can only have one of them be negative because one of these has to be positive, one of these has to be negative or negative positive because this is a negative. So I'm going to have this be 3 and this be 1 because I want a -6. So that will be negative and a positive 1. Okay. Let me erase this stuff over here and get my pen back. So I can cross this out. This is now factored like this. Hey, there's a 2x plus 1 and there's 2x plus 1. So I'm going to cancel this with that, leaving one of them down here. So our answer is going to be x minus 3 over 2x plus 1. If I want to put excluded value, I can put excluded value. I'm running out of room, so I'm not going to. And I didn't say to put excluded value. Usually it will tell you to. Okay, so that is A. I'm going to copy B over here. B is right here. X squared minus 3x minus 10 all over x squared minus 4x minus 5 divided by, I'm going to go ahead and change the divided just to save a step to multiplication, right? Times. And then I'm going to flip this over. 2x squared minus 5x minus 7. Denominator is now going to be x squared minus 7x minus 18. Okay, we just need to factor all of these, right? So factor, 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 factor. So if I factor this, you know, x squared is just x times x. Factors of 10, that's easy to factor. That's 2 times 5. I need it to be a -3, so that means the 5 needs to be negative and the 2 needs to be positive. See, so you don't even have to use the, you can use it if you want to, but at this point you should be able to do it without it. Okay. Same thing factor here. My x squared is going to be x, sorry, the keyboard is slipping around, times x. And then my 5 is going to be 1 times 5. And I need it to be a -4, so I'll make a -5 and a +1, right? Times, and I can see that these two are already the same, so I can go ahead and cancel them out. Now this, I'm going to factor. Okay, factor of 2x squared is 2x times x. First I'm factoring this. Now I'm going to factor the 7, so I can either put 1 and 7 or 7 and 1. Well, I don't want it to be 15, so I'm not going to put the 7 over here. So I'm going to put the 7 over here and the 1 over here and check my inside and outside terms to make them equal -5. Well, my outside term, when I multiply 2 times x, that's 2x. My inside term is 7x. I can make that be -5 if the 7 is negative and the 2 is positive. What did I say? +2 right here. And for the bottom one, I need to factor this. So x times x gives me my x squared. Then I'm going to factor the 18, -18. Let's see, 3 times 6 is not going to work, but 2 times 9, a 2 and a 9 makes 7 if the 9 is negative and the 2 is positive. Look for anything that you can cancel. I can't cancel anything like this, but I do see an x plus 2 here and here. I see an x plus 1 here and here. And that leaves me with these two. So my answer is going to be 2x minus 7 over x minus 9. I have some room, so I'll put excluded value x equals 9, right? If this is a 9, then we're getting a 0 there. But please box your answers so it's easy for me to see and grade. Well, before I forget, what are we doing on Wednesdays now that we're done with the standards quizzes? I'm going to put some kind of assignment on Wednesday. I'm going to probably do a Delta math assignment. So I'll post a Delta math assignment tomorrow, and whoever does it gets credit for being there on Wednesday. Whoever doesn't will be marked absent. So, and I'll post it before standards quiz time, sometime between 8 and 10, I'll post it, and I'll leave it up there all day because it's not a quiz. So you can do it anytime on Wednesday, but look for it between 8 and 10, okay? All right, this guy over here, I need to erase some of this, so hopefully it's okay if I erase this stuff. You guys already have that down. Okay. If you're leaving early, I generate the reports and see how long you stay in class. And if it's a very low amount, then you get marked absent or just marked as asynchronous work. Okay, C. Sorry, pen back. C. What does C say? I'm going to write C up here. Put it up here. C says 15x minus 20 over x minus 5 times x squared minus 2x minus 15 all over 3x squared plus 5x minus 12. Okay, a lot of things we can factor here. I can factor this, and this. This I can't factor because it's already in lowest terms. But what goes into 15x and 20, guys? 5, right? So I can take out a 5 out of it. If I take out a 5 out of this and this, I'm going to get 3x minus 4. And then the x minus 5 on the bottom just stays like that. Now I'm going to factor this guy right here. So factor, break it down. Okay, so break down the x squared, that's x times x. Break down 15, well, 15 is 3 times 5, and that differs by 2, so we're on the right track. I need a -2, so I'll put a -5 and a +3 to make a -2. Okay, now I got to factor this trinomial, so I'm going to start with a 3x squared. That would be 3x times x. Now I'm going to factor 12. It's a little tricky because you can use 2 and 6 or 3 and 4. Well, I know I would need a 5, so is it 3 and 4, I believe. And because let me check it out. Let me check out the outer terms. 3 times 3x is 9x. And then 4 times x is 4x. Yep, that's going to give me 5 if I make this positive and this negative. So the negative is going to go right here, and the positive's going to go over there. Okay, and that is how you factor without a table. Okay, I'm going to erase this stuff because I need to cancel some stuff now. Now let's look what's the same that we can cancel. Ooh, 3x minus 4, 3x minus 4. I see an x plus 3 and x plus 3. And I see another one, x minus 5 and x minus 5, leaving you only with 5. So the answer to C is just 5. Okay, but you had to show all this work to get that answer. We just didn't get it. Okay, I need to erase this stuff, so I'm going to do that next. Okay, we're going to copy down D. So D says, oh, I don't want to write in red. Let's change to dark blue. 4 over 2x plus 3. Looks like we have an addition problem here. So I'm going to put the addition really far away because I know I'm going to have to multiply by something to make a common denominator. So x squared minus x minus 2 all over 2x squared plus 5x plus 3. I'm going to go ahead and erase this stuff too because it's kind of getting confusing. Okay, clean it up a little bit. We need a common denominator between these two. Well, we're going to have to factor this first to see what this is. Okay, so to factor 2x squared, that would be 2x times x. To factor 3, well, I could put 1 and 3 or 3 and 1. Since it's positive, I'm going to want the 3 to be here and the 1 to be here because I'm going to need a positive 2x and a positive 3x. So plus and plus. Okay, the 1 and 3 wouldn't work if I reversed that. Well, you notice these are both the same. That's a 2x plus 3 and that's a 2x plus 3. So I just need to multiply this side by this x plus 1 to make a common denominator, x plus 1, like that. Okay, so erase this inside stuff here. Change my color. So that means I need to distribute this 4 times this x plus 1 here, which is 4x plus 4. Okay, and let's go ahead and just copy this stuff. Plus x squared minus x minus 2. And the bottom is just going to be 2x plus 3 times x plus 1. Okay. Now we combine like terms for the numerator. So we're going to start with the x squared equals, let me put it up here, x squared, and then positive 4x minus 1x is 3x, and then positive 4 minus 2, that is going to be plus 2. All over these two things multiply together. We do not multiply the denominator out, only the numerators you multiply stuff out. Okay, and we're probably going to get to factor this, so let's try and factor this, right? Pretty easy. X times x for their x squared, and then 2 is going to be 1 times 2, and we need 3, so plus 1 plus 2. Look what happens here. These two, this x plus 1 is the same as that x plus 1, so our answer is this over this, x plus 2 over 2x minus 3. I could put an excluded value, but I'm just going to skip it for now because we've got a couple more problems to do. Okay, so E here, let's look at E. Let me write Let me erase some of this stuff and go ahead and copy down E while I'm erasing this stuff. Need more room too, so I think I'm going to move my other problems out of the way that I already used. I'm going to move that out of the way and move this out of the way and move, I'll put that down there. Let's write down E. E says 6x minus 4 over 3x squared minus 17x plus 10 minus 1 over x squared minus 2x minus 15. Okay. See, three things that we can factor. Okay, three things that we can factor. I can factor this guy right here, what goes into 6 and 4. That would be 2. So 2 times 3x minus 2 will give me 6x minus 4. I can factor this one right here. To first factor the 3x squared, 3x times x. And then the 10 is going to be 2 times 5. Yep, 2 and 5. I knew that was right because 3x times 5 is going to give me 15x. The inside term is going to give me a 2x. I need them both to be negative. So this is going to be negative and that's going to be negative, negative, negative. Okay, let's go ahead and factor this one over here. X squared is x times x. 15 is 3 times 5. It's a negative 2, so the 5 will be negative and the 3 will be positive. Okay. So let's see, since this is subtraction, we need a common denominator. Well, they both have an x minus 5, so that they have that in common, but this one doesn't have an x plus 3. So I need to multiply this whole thing by x plus 3. It means I need to multiply this by, oh, you know what? Let's not do that yet. I see something. Let me see. First, I see that this 3x minus 2 can cancel. So I'm going to cancel that. I just realized that right there. Those are going to cancel. And then this still doesn't have a, that's good. Okay, still doesn't have x plus 3. So we can multiply by x plus 3. So this is going to be x plus 3 times the 2 here. Okay, that 3x minus 2 canceled, but the 2 didn't. So we need to multiply the 2 times x plus 3. 2 times x plus 3 is 2x plus 6. Okay, in the numerator. And the denominators are now the same. Minus 1 for this minus 1 right here. And then the denominator is just going to be x plus 3 times x minus 5. Okay, and so I need to make this, need to combine these two to be 2x plus 5 over x plus 3 times x minus 5. You cannot like cancel these 5s, right? Because they're connected by like a plus here to this 2x and a minus here to this 1x. So I see the answer is correct over there. That's reassuring me. Okay, that's E. Okay, lastly, F. I'm going to move F over a little bit here. Move F way over here so I have room. And let me change my pen color. F is x squared minus x minus 2 all over 4x squared minus 7x minus 2. Instead of division, let's change it to multiplication and flip it over. So if I flip it over, I get 3x squared minus 8x minus 3. Denominator is x squared minus 2x minus 3. Okay, I'm going to have to erase some of this here. You can start factoring while I erase this. Okay. Okay, since I see trinomial, all of these can be factored, right? Because they're all trinomials. And so when I factor x squared minus x minus 2, that is going to factor down to x times x, 1 times 2, right? This guy right here. X times x, 1 and 2. I need a negative 1. So the 2 needs to be negative and the 1 needs to be positive. For this one, I want to factor the 4x squared first. So 4x times x. Then I'm going to factor the negative 2, which will be 1 and 2. Yep, 1 and 2, because I want a 7. So this is 8, and that's pretty close to 7. And then we got the 1x here. I didn't need it to be -7. So -8, +1. So plus here, minus here. And look, the x minus 2's, boom, those are going to cancel. That's nice. Okay. And then let's go ahead and factor 3x squared. So 3x times x. That's how we're going to factor the 3x squared. And then the 3 is 1 and 3. When I multiply the 3x times 3, that's going to give me 9x. When I multiply the 1 times x, that's going to give me 1x. I want a -8, so this 9 better be negative, and that 1 better be positive. So plus here, minus here. Let's go ahead and factor this one. So x squared is x times x. And then 3 is 1 times 3. 1 times 3. And I want a -2, right? I want a -2, so it's going to be -3 and +1. Oh, look, there's 2 x minus 3's. Those can cancel. And oh, there's an x plus 1 here and an x plus 1, so those can cancel. So all we are left with is 3x plus 1 over 4x plus 1. Can I cancel the 1's? No. Can I cancel these x's? No, because there's a plus in the problem connecting to 3x plus 1, okay? So it's just like that, nothing else. All right, that was F, the last one from the classwork. Okay, so I need to go to the next slide. I got to clear this out. And the next thing, this is your homework, okay? So I just wanted to say go over maybe 5 and 12. What do you do when they're adding and there's nothing in common? Okay, so if we look at number 5 here, pen back. And they have nothing in common. So what I need to do is I need to take this 2, there's a plus here, this 2, and I need to multiply it by everything over here, 3x times x plus 6. And the same thing for the top, 3x times x plus 6. Okay, now they're almost the same, but this now needs a 2. So I need to multiply, I'm going to put this as 5. I need to multiply by 2 over 2. Okay, because this didn't have a 2 like this does, so we have to multiply this one by 2. So we have to multiply this out. 2 times x plus 5 is 2x plus 10. Then we got to multiply this. Well, 4x times 3x, that's 12x squared. And then I'm going to multiply that by the x plus 6. So 12x squared times x is 12x cubed. It's okay, we got a cubed. 12x squared times 6 is 72x squared. All over, we can go ahead and multiply the 2 times 3x. That would be 6x times x plus 6, but you don't want to multiply everything else out. Okay, combine like terms. We start with this. So 12x cubed, and then, oh, we have no like terms. We just need to put them in order, highest to lowest. That's the highest. This is the next highest power, plus 72 x squared, then plus 2x plus 10. Okay, and we don't know how to factor that yet. Actually, we could factor that. Oh, so the bottom one, we don't want to multiply out. We just leave it that times that. You know what? We might be able to factor this by grouping. If I take a 12, yeah, let me see. No, it's not going to work. Okay. I'm going to get x plus 6 when I factor this, but this is going to be like x plus 5. Just make sure I did that. 2x plus 10. 4x. Yeah, that's correct. Okay. So that's going to be as far as we can go with that one. Okay. I wanted to look at number 12 here with you. I'll write it up here so I have room. 12 is 5 over x minus 4. So I'm doing some of your homework with you. Minus 3 over x plus 1. Totally nothing in common for these denominators. Okay. So what that means is I need to multiply this one times this one and that one times that one to get them to be the same. So I'm going to multiply this side by the x plus 1 over x plus 1. okay? And this side, I'm going to multiply by the other one, x minus 4 over x minus 4, okay? Because these are completely different. So you just multiply them by each other. So I'm going to multiply the 5 times the x plus 1, which would be 5x plus 5. And then remember this negative. This is a negative 3. So negative 3 times x is negative 3x. Negative 3 times negative 4 is positive 12. Remember that. And then the denominator is just going to be x plus 1 times x minus 4. Doesn't matter if I put it in this order or that order. Okay, combine like terms. 5x minus 3x, well, that's 2x. And then 5 plus 12 is 17. That's not going to factor. 2 doesn't go into 17. We have x plus 1 and x minus 4. So that's about as far as we can go. That's how we combine them. That's how we subtract the two terms to make a common denominator. So I just wanted to do those two examples so you're not lost when you're doing your homework, okay? So that's basically how you do the rest of the homework. Remember, it goes all the way down to 26. I just took a screenshot of the middle part. So yeah, those two homework problems done for you. All right, so